Okay, in this video we are going to be looking at scientific notation. So we're going to be changing numbers from exponential notation to scientific notation. We'll also, I guess, be looking to convert them back and forth. We'll also do some operations and maybe try some calculator work with scientific numbers as well. To begin with, scientific notation is a notation that scientists and other people too use to express really big numbers, and not like a million. That's okay, but we're talking trillions, cadzillions. Is that a number? Anyway, real big numbers, or express real small ones. And what we do is, like if you look at this number here, look at all the wasted zeros that are in there. So rather than putting all those zeros in, they're important because that gives you an aspect perspective of how big the number is, but rather than putting them in, we express them with a power of 10. And actually, when we're comparing numbers with powers of 10, we can get quite a bit better idea of how much bigger one number is than others just from looking at a power of 10. So here's some examples. The number of particles in a mole of oxygen or a mole of something is this number, huge. Our debt, probably way too big. The weight of a grain of sand is about that much. So those are some examples of numbers that might be worth it to change to scientific notation. So a scientific notation number contains two parts. It has a number part and a power part. So the numbers here are just giving you, I guess, an indication of an approximate amount, or the numbers that mean the most, that are significant. And then this number over here, the exponent, tells you how big or how small that number is. So there's two parts to the number. And we need to be able to convert back and forth. So this is in scientific notation. We also need to be able to convert that to the regular number, so the 2, 3, 6, and some stuff after that. So let's try that here. So to convert from decimal notation to scientific notation, first thing is you move the decimal so that it is to the right of the first non-zero number. Okay, let's look at this number here. So I'm reading from this side, and I need to move the decimal from wherever it's at. Like here, there isn't a decimal. So if there's no decimal written in a number, we assume it to be the end. So I have to move it from here all the way to the right of the first non-zero number. So I'm coming in the number, there it is right there. So I need to move that decimal there over to right there. So I'm just going to write that. So 6.02, and there's another 2 there. And then there's a bunch of zeros. Rather than writing all those, I'll just maybe round my number. We'll talk more about rounding and how to round numbers properly in another video. Okay, so right at the first non-zero, got it. Express the number of places you had to move the decimal as a power of 10. So I've got to go times 10 to the something. And now I moved it 3, 6, 9, 12, 15, 18, 21, 22, 23. So 6.022 times 10 to the 23rd, that is the scientific notation for this decimal notation. And notice how much easier that is to write. Let's try this next one. So decimal not written, so I assume it to be here. And I'm going to move it so it's right there. So it'll be 7.2, why don't we round it to 7.26? Again, we'll talk about rounding later. Times 10 to the, now how many times did I move it? 1, 2, 3, 5, 6, 7, 8, 9, 10, 11. Okay, so now I guess you can compare these two numbers here, but look at this comparison. It's easy to tell that something to the 23rd is lots larger than something to the 11th. Also, I didn't read this part here. If you have a large number, the power of 10 that you get here is a positive number. But if you have very small numbers, less than 1, like this one, then the power here will be a negative number. And you'll see what I mean when we go through it. So, rule is, let's convert this one. Move the decimals, and the decimal's right here now. So that's right after the first non-zero number. Okay, 0, 0, 0. Here's a 6. So it has to be right to the right of that, so right there. So my number is going to be 6.7 times 10. Now this time, notice we're moving this way, and it's a small number, so my exponent is going to be a negative number. 1, 2, 3, 4. I moved it 4 places. Again, when you compare 11 to negative 4, this number is significantly smaller, and I'm not really even looking at the first numbers, I'm just looking at the exponent. Okay, maybe try some of these on your own. Here's 4 to try. Maybe press pause and try them on your own, and then press play, and I'll reveal the answers. Okay, you're probably back. Hopefully, those are the numbers that you got. That last one was a tricky one, eh? The decimal was already in the right spot. But if you had to convert it to scientific notation, you could say times 10 to the 0, because you didn't have to move the decimal at all. Okay, so we've gone the one way, but it's probably a good idea for us to be able to go the other way as well. So here I have a number in scientific notation. It'd be good to write that in decimal notation. So to do that, we do the exact opposite of what we just did. It looks like I'm going to have to move my decimal 5 times. Since this 5 is a positive, it means this number is a big number. So which way do you think you should move the decimal? Well, to get a big number, I'm going to have to move the decimal to the right. So what I like to do is I like to go 7.89, and now I'm going to move it 5 places. So 1, 2, 3, 4, 5, and my decimal winds up right there. And I have 3 nice little valleys that I can put some zeros in. Now, this wouldn't be my answer because there's 2 decimal places in it. You can't have 2 decimal places in a number. So I would rewrite the number as 789,000, and I could put a decimal there at the end if I wanted to. So this number here is actually 789,000. Okay, here's another one. 2.51 times 10 to the minus 7. It's a small number, therefore which way is the decimal going? To the left, that's right. So I've got 2.51, and I've got to move the decimal 7 places to the left. So 1, 2, 3, 4, 5, 6, 7. And my decimal will wind up right there. So I'm going to have to put in 1, 2, 3, 4, 5, 6 zeros. So my answer will be 0.123456251. Often in front of a decimal, just for, I don't know, it's standard template kind of thing, we often put a 0 in front of there, probably just to set it off that that is a decimal and not like a period. So this will be the decimal notation of that one. Why don't you try a couple? There's 3 to try. Press pause, press play when you're ready. Okay, there's what I got. Hopefully you got something that is similar. So we've seen how to change numbers from scientific notation to decimal notation and vice versa. But with these numbers, really what we're doing is we're going to be using these numbers in some kind of calculation, like these ones here, where I've got 2.34 times 10 to the 5th multiplied by this number or these other ones. And often on our calculators, we'll see some scientific notation. So let me just show you on a calculator, and mine's a TI-84, but how you could do those multiplications. Often people will, when they're using this multiplication there or this multiplication, I guess those ones are okay to use multiplication, but this one right there, this one you don't want to hit the times button on your calculator for, because your calculator has a special button to take care of that whole times 10 to that thing. So if I were doing this product there, I would go 2.34, and then on my calculator there's this little EE button. So look for that on yours, or an EXP button it often is. So 2.34, and then I got to go second EE. Notice it puts an E there, just indicating it's changing it to scientific notation. And then I put the 5. So there's my number, 2.34 times 10 to the, that's what that E would mean, times 10 to the 5th. Okay, good. Times 5.2 EE, there's my EE button, to the minus 8, minus 8. Okay, there's my product. I say go. So my answer is 0.012168. Let me write that down. 0.012168. So that's the number it got on my calculator. I may want to rewrite that in scientific notation. And so I'd move the decimal to right there. So it would be 1.2168 times 10 to the, since it's a small number and I'm moving to the right, this would be a negative 2. Let's try one more. Try one more. Okay, so I've got, let me clear this thing. So 2, well, I don't have an EE button. Let's do an EE question, just set. Sorry. Do I have another one? There's one. There's one. Let's do an EE button 1. So I have 3.2 times 10 to the negative 6 times 1.6 EE negative 3. Go. 5.12 times 10 to the minus 9. 5.12 times 10 to the minus 9. And that would be the answer to that. Sometimes when you multiply numbers like these ones, you'll get a number on your calculator like you saw in that last one. Let me just pull it up again. So if it comes out looking like this, then you need to identify that as 5.12. The E means times 10 to the minus 9. Okay, so just be careful with that. Here's a couple of good questions. If I've got this many moles of something and I want to multiply by that, I could do that on my calculator. Here's another concentration kind of question. If I have this many moles in this many liters, it could give me a concentration. Let's do that one. So where's my calculator? Right there. So let me clear. So 5.11 to the minus 3 divided by 1.1 times 10 to the 2. Go. Oh, so it's giving me a number 4.65, call it. 4.65 times 10 to the minus 5. 4.65 times 10 to the minus 5. And the answer to that would be moles per liter. But that would be my answer in scientific notation. If I wanted it in decimal notation, I could do that. It's 4.65. It's a very small number because of the negative 5, so I'd have to move my decimal to the left. So I'd move my decimal to the left 5 places. It needs 1 to get past the 4, so then another 4 zeros. So decimal and 4 zeros, and then 465 moles per liter. And typically we throw in a 0 out front. So that would be my answer in decimal notation. Here's another one, and you can maybe try this one. Maybe I'll have you do one with division. Here's a couple of complicated ones. Maybe press pause and try these ones and see what you come up with, and then come back and take a look. Okay, I'll just reveal the answers here. Whoops. Delete that. Delete the answer thing. And delete this answer. So those are the answers that I came up with. Watch how I do that one though. I'll do that one on its own. So if I have a complex fraction like this, I'd probably put that in brackets. So I'd probably put a bracket first and then go 1.43 times 10 to the 4 divided by 6.78 times 10 to the minus 3. And then I'd close the bracket, and then I'd say divide, and then I'd open a new bracket and go 5.45 times 10 to the 2 divide 2.11 times 10 to the 5, close my bracket and say go. I hope I did that one at the first right. Yep, I did that. So now I get 8.17. It looks like I rounded it. And that would be 3.678, I think. Yeah, 8.17 times 10 to the 8. So try those and practice those. on the online quiz or in some worksheets. Practice that you can change from scientific notation to exponential or scientific to decimal notation fairly easily. Okay, and that would be the end of our scientific notation.